G'day, it's Lance from Motive Power, back again to talk about the next episode in our off-highway vehicle design series. Today we're talking about probably the most expensive item, the axles. As always, what I say to you is only guidance. It is not advice. It's information that you may care to investigate further on your own. But today we're talking about axles. And why? Because they're generally the biggest, most expensive and longest lead time item in your design. If you get it right, fantastic. If you get it wrong, you've got a big problem. It takes lots of detail work to select the right axle. Don't be afraid of it, just do the work and get the right product for the right job. But as always, we're going to start with some terminology. And what type of axles are there? Well, there's quite a range. We start with a simple, rigid, non-steer axle, non-drive axle that you might use on a box trailer. But really, we're going to talk about drive axles and mostly drive steer axles. So let's look at some of those versions that are available for you. So here's a small cluster of Dana axles, only because they've got a reasonable catalogue and I can find some pretty images. Rigid drive axles, independent front axles, independent suspension, planetary drive, steer axles, and so forth. It's quite a range, and this is only part of it. This may look more familiar as something you might see on highway. If this was two axles, these rear two axles, this would be a tandem. Together they're a tridem. Obviously, three axles carries more load than two, but it's an issue here with torque distribution. Because these drive-through axles use differentials to split the torque between the through drive and the axle, and differentials typically split torque 50% each way. Of 100% of the torque coming into here, 50% will go to this axle. 50% will go out the back. From that 50%, 25% will go to this axle and 25% will go to the rear axle. Hence, the axle that's going to spin out first is this front one. Good interaxle diff locks required. So, I just mentioned diff locks, all sorts of different types to override the torque split automatically given by differential. A free or an open diff has no additional control, but there's limited slip differentials, there's locking diffs, there's no spin diffs, and all sorts of variety as every inventor's come up with his own version. Personally, I prefer a locker because you know what's happening. Of course, you've got to remember to unlock at a time too. No spins tend to be thought of fairly well, but can be a problem because they actually disconnect the faster wheel. So if you're turning a corner, it will disconnect the outside wheel and drive through the inside wheel, which can be a problem. So you would have heard the term 4x4. That relates to the I want to say wheel configuration, but it's not quite right. It's really the hub configuration. 4x4 means 4 hubs, 4 of which are driven. Your family car is probably a 4x2, 4 hubs, 2 of which are driven. And 4x4, of course, is a normal 4-wheel drive utility such as a Land Cruiser or a Ford Ranger. But the terminology can be applied to much bigger vehicles, and regularly is. It doesn't give you the orientation, the organisation or configuration of all the axles, but it does give you an indication as to how the system works. And let's look at an extreme example. That monster is a Tatra 16x8. So Tatra is a truck manufacturer in the Czech Republic, known for making trucks for extreme applications. This is an 8-axle truck, hence 16 hubs, 8 of which are driven. Quite a monster. I believe they go up to 14x14, but yeah, big truck. Now there's always more terminology to be considered. So back to the whiteboard and let's draw a basic vehicle. And we'll just put a simple body on it. Some wheels, tires. That is the wheelbase. That is the track. Now, having got wheels there, what do? Well, they actually create tractive effort in that they push on the ground, depending on how many axles are driven, to create tractive effort. You could think of that as the amount of grunt or pull the vehicle has. There's another term, put a hitch on here and we pull on something with that hitch. That term is drawbar pull. They're often used interchangeably, but that would be wrong. Tractive effort is the total generated by the vehicle. The drawbar pull is the total drawbar pull it can create after it has moved the vehicle. There is a difference between the two, and the difference is what it takes to move the vehicle. So when you have designed your basic vehicle, you want to select axles, irrespective of the brand, there'll be a thing like this. This happens to be a Dana-based form, in fact an Excel spreadsheet, and it defines the vehicle and what you're doing with it. Loads, dimensions, tyres, horsepower, accessories, transmission types, gear requirements. Here we go, brakes, differentials, steering cylinders. It goes on and on and on. If you're using a hydrostatic transmission, more information is required. And this is the key bit you should already be familiar with from our video on tyres. You'll remember that tyre selection is based on a duty cycle. So here on this example, so many times forward, reverse, laden, unladen, because it's a loader, a certain amount of time digging. And Dana kindly give a description of each of the operations to assist when you're doing a duty cycle. Every manufacturer has some version of that, and there's a lot of detail involved,
and a lot of detail is necessary. However, sometimes being exactly precise is not to your benefit. I have had, for example, an application rejected for an amphibian vehicle because the legal eagles at that OEM decided that the risk to their reputation of the vehicle was too high. One of the problems that happens in service is that this is a initial design, and then in service there's extra options added and so forth, and it gets heavier. Few people ever go back to their manufacturer to actually update. The reason for doing this is A, to get access to the right axle, but B, is to get warranty. If you want warranty on your vehicle, you need to have this sort of form not only filled in but signed off. And these days most companies won't supply an axle unless you've got one of these signed off.
So, designing. There's a few factors to consider outside of the pure technical. As I've said, it's a duty cycle question all over again. Hopefully you got that nailed at the tyre selection stage and you can use the same results here. It is a question that will get asked again throughout the design. So work out the loads. The loads on axles is not just how much weight it's carrying, it's the torques as well. Invent a duty cycle and fill in the damn forms, no matter how much of a pain in the butt they are. Now, in filling out those forms, make sure you allow for specification creep. Generally, things end up heavier than they were expected. And often, if the vehicle is a success, marketing will want to update it, expand it, increase its capacity, add extra features. All of that adds to mass, and you really don't want to be revisiting your axles in that situation. If it's not a symmetrical vehicle, for example a 6x6 with an axle further out the front, you may need to consider the torque split. It may be necessary to only send, for example, 1/3 of the torque to the front axle and 2/3 of the torque to the tandem at the rear. That's an issue usually faced in military trucks. Not too many big 6x6 vehicles out there outside of the military. If you're using different axles on the vehicle, and this can readily happen if you're mixing drives with drive steers or steers, you want to make sure that you can use the same wheels and tires. That means the same stud pattern and the same wheel nuts. It isn't always an issue. I run a Polaris Ranger 570. It has different tires front to back, but I'm running it close to home on the farm. If I have a flat tire, I can walk back, or I can just drive it back on the flat, or whatever, or I can call for help. In a military application, for example, with bigger tires, where I could probably chuck a few Polaris tires in the back of the Ranger of different types, you really only want to be carrying one spare. So make sure that your front and rear tires and wheels are the same. Now at some point those tires will need to be changed. Again, not really a problem with the Polaris. I can do that with a wheel brace, and I can readily pick up a tire and wheel assembly and put it on. Big trucks, you can't do that, particularly if you're running 1825s or bigger. It's not an easy application. in a mine site application, there's actually tyre handlers. They're like cranes, but they have clamps that grab a tyre and can rotate it and go in and out and so forth. But in a lot of applications, if you're just out on an off-highway trail and you need to change a tyre, and it's a big heavy sucker, which it will be if it's a run flat for sure, can you lift it? Can you actually get it off the truck and lift it onto the axle? Can you get that flat back up onto the vehicle to carry it back to base? There are considerations that you'll need to understand for that. In some occasions, you will put essentially spikes, guide pins, on the axle hub so that you can get the tyre or the wheel lifted onto those pins, and then you can slide it in. It just makes it easier, but always make sure you can change tyres in the field. And yes, it's not unusual for vehicles to have a crane or some sort of ramp. Now, we've talked briefly about tractive effort, and generally you're looking to maximize your tractive effort. Let's face it, everybody wants the most grunt out of their vehicle, but too much grunt can oversize your axles and oversize your budget accordingly. So you need to be sure that you're using the right size axle and that it can't handle or it can't be subject to excessive torque. That's where wheel spin comes in. Controlled wheel spin at a known position is your friend. It will prevent the axles being overspec'd. Even in very heavily laden, high traction environments, you probably won't have a coefficient of friction with a tyre greater than about 0.8. So you don't need to size your axles for anything more than whatever torque is related to your weight times 0.8. It will save you a lot of money in the long run. Now, differentials are a whole subject on themselves. I'm not going to look at the different types, but I am going to say to you, you need to very carefully consider them. The simplest one to fit is a simple free diff, and a lot of cars run happily with that. High performance cars, however, have some version of limited slip. And because they don't want one wheel breaking traction and therefore robbing the other wheel of its torque. So in an off-highway application, there are various choices. Because you're off-highway, you're on poorer ground, you're always looking for traction. And yes, there are a variety of limited slip differentials available with clutch packs, ball ramps, whatever, that can do the job. Diff locks are generally the best, but you must be sure your operator can remember to unlock the diffs when he gets to better ground. One of the trickiest applications is on articulated vehicles. Because they're bending in the middle, on each axle, one wheel is going forward, one wheel is going backwards. That technically means the differential has to be an open diff, a free diff. Anybody putting a lock diff in there or an LSD is going to cause large forces to be generated in that diff center as it fights the steering effort. I've done a lot of work with underground loaders, and yes, it's because they're in bad conditions, they do tend to have either lock diffs or LSDs in the front axle, the one that gets the heaviest load from the bucket and therefore needs the most traction. Generally, the second axle The rear axle does not have any sort of locker. But every now and again, that sort of vehicle comes out and goes into a workshop on a concrete floor. And when you start steering on a concrete floor, you are exerting high loads. What will happen in that situation with a lock diff at the front and a free diff at the back is when it's steered, it will tend to be the rear that will move more than the front. It's something different. Diffs are a complicated question for you. Personally, I prefer locking diffs because then I know when I need it, it's locked. Of course, I have to remember to unlock it. Now, in selecting axles, you're also going to get faced with the question of what brakes do you want? That again is a topic that is a whole subject on its own, and we will do another video on that. But you need to think about the application. You've got dry discs, multi-discs, drum brakes. If it's hydrostatic drive, of course, you've got hydrostatic braking. It's a decision that needs to be made at the time of selecting your axles. So have a good think about the application and how it is going to survive in that application. There is very often not a perfect choice, and we'll cover that a little later. So that's the background on axles. They are the most, in my experience, the most expensive, most long lead time items. The vehicles are generally built around them, so you don't have the option of getting it wrong and making a simple fix. It has to be selected right the first time. I trust my suppliers because I know them well and have known them for many years, but I always verify what they're telling me is true. I ask them to give me a copy of that spec or that calculation or that catalogue so I can cross-check. Remember, trust but verify. And then when you've done that and you're happy that you've covered all possible bases, close the book on axles and move confidently into the next phase of the design.